Hi, third graders. Welcome to your math lesson for today. We're continuing on with area, and today we're incorporating the distributive property, which is something you already know. So before we get started, please grab just a scrap piece of paper and a pen or a pencil so you can give it a try as we go through. And here we go. So your learning goals by the end of this are that you can say, I can apply the distributive property as a strategy to find the total area of a large rectangle by adding two products. Remember, a product is what you get after you multiply two numbers or two factors. All right. So here we have, you can see a rectangle that's been split into two parts. And we are going to find out what the dimensions are. So we can see that the dimension here of this gray part is 5 centimeters. And this part is 6 centimeters. So if we're thinking about the dimensions of that to find the area of this part here, we can multiply 5 times 6. Now we don't know about this one because we don't know what the dimension is yet, but it is 3 centimeters. So again, we can find out the area of this part by multiplying 3 times 6. Again, the length times the width, which gives us 3 times 6. And if we're trying to find the area of the whole rectangle together, we just need to add these two expressions or the products of these two expressions, which in this case would be 5 times 6 plus 3 times 6. You've seen things like this before. That would give us, oof, my little bar would go away, 30 plus 18, because 5 times 6 is 30, 3 times 6 is 18, and that gives us a total of 48 square centimeters. Please make sure you're including that label. I know a lot of us, the teachers, have noticed that you can get all the way down to what the total area would be and you forget your units. So don't forget that it's a square unit, okay? When we think about the distributive property, we would write it like this. So 8 times 6, which is what we end up doing, because if we add this whole side here with the 5 and the 3, we actually get 8 centimeters. So you can do these different steps, but in the end, it ends up being 8 centimeters. So 8 times 6 would be the same as doing 5 plus 3 times 6, and then you end up getting 48 centimeters. Okay, make sure you have that pencil and paper ready because you're going to give it a try now. All right, here we have a very similar rectangle. It's a little bit different though. Let's have a look at our dimensions. So this time, this side is 6 centimeters and the top is 8 centimeters. So pause the video here and go ahead and figure out the area of this gray part of the rectangle. All right, so you should have written 6 times 8, and you probably got 48. And we'll see that down here in just a moment. And then we need to know the dimension of this white part of the rectangle. So it is 4 centimeters. So again, pause the video, figure out the area of this part of the rectangle. All right, so you have 4 times 8. 4 times 8 would be 32. So if we come down here, we know that we can add these two expressions together to get this whole part of the rectangle. Imagine this would be very helpful if you didn't have this broken up and you had a larger number that you needed to break in half to make it easier to multiply. That's why this would be helpful. Again, if we go through solving each of those expressions to get the total area, we would get 48 plus 32. Pause the video, go ahead and figure it out. And the total area would be 80 square centimeters. Again, if we look at it the other way, if we're thinking about the distributive property, 6 times 8, again, 6 times 8 plus 4 times 8, the area of each of these sections would give us the same as doing 6 plus 4 times 8. Again, that would be the same as saying, can you guess what it is? 10 times 8. So, there we go, 10 times 8, which again would give us 80 square centimeters. Today for the work, you have our Module 10 or our Module 4 classwork, Lesson 10 classwork pages, problem sets. So all you have to do is look, well, first of all, always read the instructions, but you have some different rectangles, some different arrays that are broken up for you, and you have to go through and make sure you're filling in the different products or the things that are missing, the missing numbers. So if we look at this first one together, we can see that 8 times 7, if you're thinking, where did they get that 8 from? Remember, that's what this whole side is together, this 3 and 5 times 7. So here we see 5 times 7. 5 times 7 would give us 35. We would put here 3 times 7 gives us 21. We'd put it here. We would add those together. And this number is the same that goes here. It gives us our square units, and they just added those on for you. The rest are the same. So it's pretty self-explanatory. Figure out what they're trying to get you to do. In this case, we see that there is a number missing. We see that the area or the dimensions of this part of the square are 2 times 4, but the area of this one, we're not quite sure. You're going to have to count and figure it out. Label it. So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can label 10 here and then go ahead over here. You could also know that if 2 is one of the factors here and it's 12 over here, you know that the remainder is going to be 10. So if you don't want to count, you can look over here. It'll give you a clue, and then times 4. Then for the next page, it's going to have you break things apart or add rows to figure things out. So it says, Vince imagines one more row of 8 to find the total area of a 9 times 8 rectangle. So again, you're really thinking about that, the concept of it, of the distributive property and how it helps you with area. So you can type your answer here. Please try to answer in complete sentences. And then for this bottom question, it says break the 15 times 5 rectangle into 2 rectangles by shading one smaller rectangle within it. When it says shade a smaller rectangle within it, that means you need to break it apart somehow. So you can break it apart and shade a smaller rectangle like this, or you could break it apart and shade this kind of rectangle. It's up to you, whichever way you want. But you need to completely break it apart. So imagine it's like a piece of paper that you've cut. So you can break it horizontally or you can break it vertically. It's up to you. One thing I do want to let you know, though, is it's not saying shade in a smaller rectangle like this. Okay, it has to be completely all the way down the middle somewhere or all the way across the middle this way. All right, I hope that makes sense. If you have any questions, reach out to your teacher. They can help you. And happy learning.